What if you could erase the past without going back in time? Welcome to episode 3 of the Unreal Experiments series. In earlier experiments, we saw that tiny particles of light create a wave pattern when no one checks their path, and a particle pattern when we try to see which slit they go through. The key idea is simple. If we know the path, we get particle behavior. If we don't know the path, we get wave behavior. This which path information decides what we see. Now, scientists took this one step further. They designed an experiment where a single photon is split into two linked parts. One part goes to the screen and creates a result. The other part carries information about which path was taken. These two parts stay connected through quantum entanglement, meaning what happens to one is linked to the other. At this point, everything seems decided. The photon has already passed through the slits, it has already hit the screen. And since the path information exists, the result should be particle-like. But then scientists make a choice after all this is done. They either keep the path information or they erase it. Erasing doesn't mean deleting something physically. It means arranging things so that it becomes impossible to know which path the photon took. The information is no longer available, even in principle. And now comes the surprising result. When the path information is kept, the pattern shows particle behavior, but when that information is erased, the wave pattern appears again, the same pattern that should only exist if the photon never had a fixed path. This is called the quantum eraser experiment. Some versions go even further. The decision to erase or keep the information is made after the photon has already been detected. So it looks like a later choice is deciding an earlier outcome. This doesn't mean we are changing the past, like rewriting a story. What it shows is something deeper. At the quantum level, events are not fully defined until all the information about them is settled. The photon does not pick one clear path in the way we expect. It exists in multiple possibilities, and what we observe depends on what information is available. If the path information exists in a measurable way, we see particle behavior. If that information is erased, we see wave behavior. So the result is not just about what happened, it depends on what can be known about what happened. Physicist John Wheeler described this idea by saying that no phenomenon is real until it is observed. Even Einstein found this uncomfortable and called it spooky because it goes against how we expect reality to work. In everyday life, once something happens, it is fixed. But at the quantum level, what we call the past depends on the information we have about it. So instead of thinking that reality is erased, it is more accurate to say it was never fully decided. And that leads to a simple but powerful question. If information decides what we see, does information define reality? Follow for the next episode where this idea goes even further.